So the second part of today, we are going to take the theorems that you guys learned last time where you knew lines were parallel, and we're going to turn them into converses. So what do I mean by a converse? A converse is an if-then statement that's been flipped around backwards. So for instance, on these, let me give you an example. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. If I flip that around and make the converse, it would sound like this. If alternate interior angles are congruent, then the lines are parallel. So my question to you today is, do you think the converses of these are all true? So we're going to flip them around and we're going to see. So this is the question. I'm going to start with the corresponding angle converse. Do I think that that's true? So that would sound like this. If I have a pair of corresponding angles that are congruent, will it make my lines parallel? So do you guys see how I have this 60 degrees right here? So what I'm going to do is I'm going to put 60 degrees right here. And if this angle is 60 degrees, do you think that my line would have to be parallel if they're both 60? So if you notice, as soon as I turn it like this, it wouldn't be 60, right? Or if I turn it like this, it wouldn't be 60. But if I make it exactly 60, then it's going to force these lines to be parallel to each other. So the converse is going to work. So they're going to ask if you can use a converse to the theorems that you already know, and the answer is yes. And it would sound like this. If corresponding angles are congruent, then the lines are parallel. So then do you think it works for the other ones, like alternate interiors, alternate exteriors? So we're going to check. So this time I have a 40-degree angle here. What happens if I go up here and make another 40-degree angle so that they're alternate interiors? So I'm going to put my ruler up here again. If I want this angle to be 40, and I turn it like that, the angle's not 40, right? And if I turn it like that, it's bigger than 40. But if I make the angle actually 40, do you think that's going to force the lines to be parallel? And the answer is yes. So the converse does work for these. As long as you have alternate interior angles that are congruent, then your lines will be parallel. So the converse does work. So that's the goal today, is we're going to be using converses. So if you will look at your cheat sheet, on the front of your cheat sheet, will you guys find number 13 where it says supplement theorem and write LPP? Because I know some of you like to use that instead. I just want to remind you, this cheat sheet has all the old stuff with the new stuff. So flip it to the back. Bam! On the back is all of your new parallel lines, theorems, and converses that are free for you to use. So we are building. It's like building a house. We started at the bottom. Now we're going to keep adding on. So these are all the parallel line things that we're going to be using. Okay, notice over here it says if I give you parallel lines. So if you know lines are parallel, then you can say something about the angles. Okay? So maybe I'll say angles. So if lines are parallel, you can say something about the angles. Now, over here, if you notice, these are all the converses. So this is if you know something about the angles, then you can actually prove that lines are parallel. So these are opposites of each other. These are the old ones that we learned last time, and these are the new ones that we're doing today. Okay, so to do this, what we're going to do is we are going to take your cheat sheet and we're going to kind of apply it to this front page before we start getting into proofs. So what I'm going to do is I'm going to skip over some of these because you're going to try them and then check them. So I want to do one of each type with you. We're going to do number 5 together and we're going to do number 8 together. And then you guys are going to try the rest and then you'll check it. Okay? So in number 5, the first thing I want you to notice is I gave you parallel lines. Okay, so I want to ask you on your cheat sheet, do you think if I give you parallel lines, you'll be using the theorems, or do you think you'll be using the converses? And so the idea is if I give you parallel, see given parallel, you'll be listing the theorems out. Okay, so let's look at number 5. This is what you did the last time when you were doing some of that work in the book. So if these lines are parallel, then I look at what kind of angle pair I have. These are alternate exterior. So I'm going to name the pair as AEA, alternate exterior angles. And then I'm going to find X. Well, if I have alternate exterior angles, then I know that my alternate exterior angles will be congruent because I know that I have parallel lines. So this is an old reason. So x will be 43 degrees, and I will use the AEA theorem. And the reason, again, why I'm using the theorem is because I already knew lines were parallel. So I'm using some of these old ones that I've got from the old stuff that we were learning, if you know your lines are parallel. Okay? Now down at the bottom, I want you to look at number 8. We're going to go to number 8. This time I'm asking you, is it possible to make the lines parallel? Meaning we don't know, we're trying to make the lines parallel. So I'm not putting arrows on this. I'm just going to look at the angle pair that I have. I know these angles are called consecutive interior angles. So I'm going to label them as CIAs. Now, if my CIAs are something, then my lines might be parallel. So I'm going to go look at my cheat sheet over here. I'm trying to prove lines parallel. And so I'm going to look at my consecutive exterior angles, and I'm going to be using the converse here, because the converse is going to make my lines parallel. So I probably need to go check and make sure they're supplementary, because they need to be supplementary. These do add to 180. So now I know if they add to 180, that is going to make my lines parallel, so that's yes, and this is the CIA converse. So notice if I'm proving lines parallel, I'm using a converse, and if I know my lines are parallel from the beginning, I'm using a theorem. Okay, now you're going to complete this front page, and then we're going to check it and see if you're getting them right.